bits. It involves a Raspberry Pi, Arduino, big easy driver and stepper motor. And my lightning talk is a 20-second movie that pretty much describes the whole thing. So,
if I can find it.
Yeah.
That one.
That's the one.
Want to play?
Full screen if you can.
Let's do it.
Okay, so the blurry thing on the right, in the middle there is the Raspberry Pi and the Arduino and the big easy driver.
Have you already started?
Fire away.
Oh.
It did not get delivered through the window on a crane, so we didn't quite do the James Bond thing. And unfortunately, we did break the safe, but in a bad way. The thing started grinding instead of opening up. But it was there you go.
So is there a microphone or some sort of feedback mechanism to
No,
get safe?
There's a micro switch inside, and actually the coupling trigger is a micro switch every time it goes round. And the way the container works, if you get the combination right, it locks, it jams. So the idea was we just listen for those switches, and if we stop hearing them, we must have opened them.
Okay.
It's
not really efficient.
Well, no, I mean, but as soon as you get the right combination, it should block and you'll get it. But yeah, unfortunately, we sort of wore up the mechanism before we hit the right combination.
That was a design feature to stop somebody brute forcing it?
Yeah, it was the best we could do. There are various other, I mean, we could have gotten a stepper motor with a shaft encoder and found out immediately when the thing stopped moving. But
the contents of the safe should be able to replace the burnt-out motors anyway, right?
yeah, I don't actually know anymore. So,
Sorry, what's the contents of the safe?
I don't know, they're up on eBay now. I think it's just backups and shit.
Okay.
The problem is somebody said it, and then they said, here's a combination, go and test it, and somebody tested it, and then they locked it, and then the combination stopped working, so I don't know what happened there. But, yeah, it was an attempt to avoid having to call a locksmith, which we now do. And, yeah, bit of fun.
For a long time, I'm probably going to move to something else because I'm getting sick of it. But this functionality, I thought people might like. This is Arduino. I've got at home as a door controller hooked up to electric strike. Got some micro switches. Don't know anything on this. I borrowed this from Stuart, whoever it is. Thank you very much. Just to get the program going. But it's got HTML in it, right? So with Arduino, you hit the button and you. And there's a bit of JSON, a bit of JavaScript, so you've got it going back and forth, so you can actually lock and unlock the door, sensors, micro switches, read switches, things like that. The garage doors are driven by an output just on electric garage door opener. Now this is really cool, but the thing is that HTML eats up quite a bit of space. So if you look at the okay, so 67 lines, about 2.1k of index of HTML. That's real, like 3 to 8, that's heaps of pretty rare. So if you look at the HTML, which is strings of H, colon of HTML, it eats up a lot of space. So I thought, well, hey, why not compress it? So here's exactly what your web server at home does. So using a script which copies the stuff up to my server at home, fetches it down, gets the gzip data, and turns it into hex. You end up with a file that's full text, and that's the compressed gzip data. So the script basically takes the file, uploads it to my server, pulls it down to wget, does a OC on it, gets the data out, puts a seed to the little hex characters in, and if you, oh sorry, sorry, I haven't done any prep except for make sure I can get this going to show you, so I'm sorry. And John said I should tell you about this, so it's John's fault. But if I was to compile that, we're looking at, on this, which is the Mega, which is for heaps of space, I don't have all these, it's 32k, which is well over the 3 to 8 limit, right? So, I close it again, and, oops. replacement. Open up the sketch again, and this time it's actually the hex. Do a verify, and this time it's 29k. So I'll say 3k just in compressing the HTML I'm using on Arduino.
That you can store instead of the script itself.
You're right to flash.
Yeah. So that
Well, I'm actually, I like to, I'm moving away from Arduino. I haven't done this for ages because I've been doing other things, but it's stored in as a prog string. So it's in.
okay, it is.
Yeah.
Okay, cool.
It's just that it eats up program space, right? And I don't have much RAM, so I can't store it in RAM. Nobody likes to store strings in RAM. Static program space.
Anyway, it's in RAM.
What's that?
If it's in RAM, it's in program space anyway.
That's right. Yeah, so why don't I just get it into one place only?
So what are you moving to?
What am I? Probably STM, which is an ARM chip, a lot more space. A lot more fun. Build my own board. Mainly because I sort of hang out and chat with Keith and Beto quite a bit, and sort of it's rubbing off with them doing interesting things with non-AVRs. Keith likes to bang on AVR a lot. It rubs off.
They use an API.
There are IDR.
Yeah.
Well, no, he's doing a lot of ARM now on STM, which is much nicer. I just want to show you after I actually compile it and send it to the board just to prove that it does actually work. This will actually fail. And it'll fail in an interesting way, which you're going to find interesting, maybe. So, to fix that, bingo. So when you send, where is it? There. Send content encoding, Jesus. Upload again. It's verbose and Arduino.
Mike, if you want to know this, I'll post the code anywhere, it's easy.
Shit, no. Stupid. Alright. So, great, right?
Thanks, Mike.
Ask a quick question. Which browsers support GC style code?
All of them.
Really?
Yeah.
Oh.
It's pretty much standard, so as I understand. Yeah. I mean, it's usually done on the server side, right? So no server's going to really sit there and go, well, which browser do you use? I need to use it. So it's some stupid Windows compression. So it just spits out Jesus. So.
Yeah, you haven't had to per browser disable Jesus about IA3 or something, which actually supported it, which is fine.
The browsers that you say that they supported.
So we had a couple more.
I'm Josh, handles in yellow, most of you know who I am. One of my hobbies is brewing beer. Now, I blame this on a friend of mine who may be in the room. And part of the beer brewing process is to control the fermentation of the beer at a specific temperature. Try and keep it stable and within acceptable limits so that you don't end up with beer that tastes like jet fuel and probably would make you go blind. One of the easy ways to do it is to use something like this. This is an image I just found on the webpage just before. It's called a son of a fermentation chiller. There's an article on the web, if you Google it, you'll find it. It basically works by, in the rear compartment, the divider in the middle is just a baffle. It doesn't go all the way to the bottom. You put frozen bottles of water in there, there's a fan, there's a thermostat. When the temperature in the main chamber is higher than it should be, switches the fan off. Pretty simple. Except I didn't have a thermostat. I did, however, have an Arduino and some Freetronics bits and pieces. There you go, you got your plug. And so,
You can go home now.
this is the fermenter, that I had and a very uncontrolled temperature there. This is what I came up with. It's huge because the fermenter that I've got is a really odd shape and it's taller than most and wider than most. So I had to change the dimensions a little bit, and you can see just there's a little Arduino hanging off the side. So what I did, that's an inside view of it. What I did was I attached 2 of the Freetronics temperature sensors to their breakout shield and used their LCD shield and put this together. So there's 2 temperature sensors. One monitors the temperature of the fermentation chamber, the other one monitors the temperature of the ice chamber. Basically, it switches the fan on when the temperature in the fermentation chamber is above a threshold. In this particular case, the threshold was 18 degrees. But I didn't want it to just switch the fan on because the problem with ice is ice melts. And I didn't want to be checking it every 8, 12, 24 hours to find out whether the ice needed changing or not. That's why I put a temperature sensor in the ice chamber. It alerts a buzzer when the temperature in the ice chamber goes over a predefined threshold. At the moment, it's about 6 degrees. Generally, once it goes over 6 degrees, the ice is just about depleted. But there's a problem with the buzzer. My girlfriend doesn't really like things that are noisy, so she needed a way to shut it up. So I put in some additional code so that by pressing one of the buttons, you can shut the buzzer up. Now, it gives you a visual warning as well if it goes over the temperature threshold and displays an AL next to either the water or the ice temperature, depending on which one's gone over the threshold. There is an alarm on the water temperature, so if something goes horribly wrong, the fan fails, and the temperature in the fermentation chamber goes over a dangerous threshold, it will alarm. There is an article on my blog which details everything that I went to, and there's me filling the beer bottles in all my glory. I do have some of the beer here with me. So
It's great. I had it last night.
yeah. I have put the code on GitHub. It is really, really, really hacky. It is definitely not the most elegant piece of code that I've ever put together, but
it's shit code, and that's better than no code.
oh yeah.
Patches accepted.
If you want to take my code and improve it, by all means, go right ahead. It's a public repository. I'm too stingy to pay for a private repo, so if you want to go there and have a look at it, that's fine. At the end of the day, it was a solution that I put together leveraging an Arduino because it's what I had on hand. It is rather bulky. What I would like to do as the next sort of evolution from this is to take the work, I've forgotten which university it is, did some work with the AT Tiny processors and setting them up so that you can use them as an Arduino. I want to try and take a AT Tiny 85 and use a shift register to talk to the LCD and make this a heck of a lot smaller than it currently is, because at the moment it hanging off the side of the box is rather bulky. It's not heavy, but you know, I'd like to use my development board and breakout shield for other stuff instead of having them permanently tied up. I mean, there's a few dollars worth of stuff hanging off the side of it. If I can take an AT Tiny, bang a few components on it, that's a lot cheaper and, in my view, a better use of the hardware. I can take my 328 and go use it for other stuff. I mean, using a 328 to control the temperature of beer is probably overkill. So, yeah, that's it.
Jonathan is the guy responsible for designing and spending many, many hours standing beside his own CNC machine, cutting out the chassis for the CNC program. My email's not anywhere, but you can't find me. Right. Don't worry, I can supply that. Thanks. So I'm just going to go through a quick run through of sort of what sort of text we use to make it effectively. And obviously there's a few different titles here. The what the hell is that whining noise was very common around my house while I was testing this. So, yeah. So first of all, sort of what is it for people who weren't there today? Yeah, it's just a really simple, really cheap. We cut a lot of corners. Every corner we can find, we cut it. Low cost plotter at its simplest point. It's meant to be run next to your laptop on whatever desk you can find. So, yeah. And obviously, Arduino control. We chose Linux CNC because it's got quite a nice sort of GUI interface which you can see things move. And that's what it looks like when it's done, which everyone has one. That's good. And so next thing is sort of why do we build something like this? Yeah, that's pretty much it. We just wanted to get people interested in CNC, and it's a very easy way to get into something that kind of works. I sort of think of it as an idea that groups like you guys can use it, and we can get a classroom full of them to sort of build them up and get you to the point where it works, where you can pull it apart and rebuild it in whatever way you like. Limitations, you'll find these out pretty quickly. You can read through them if you want, but the main problem is just that it's slow, it's noisy, there's threaded rods, they're rough, they roll, they do okay, but they're not great. Everything is cheap, really, really cheap.
Actually, one significant point there, sorry to interject. It says 3D parts take about 3.5 hours to make. If you consider that there are 40-something kits that were made, 55 kits, there was well over 100 hours of 3D printer time went into the kits that you
Successful 3D printing.
Yeah. And the CNCing took me, per kit is about, actually this one, about 25, 30 minutes of just CNCing per kit as well.
How many cutters did you go through?
3 $70 cutters, and there was 2 other cheaper cutters as well that made really rough stuff that I had to chuck out. So it wasn't me. I had a friend running it, and yeah, he dropped a couple of them directly on screw heads, which makes the cutter just go. They look cool. Okay, so here's how it was sort of made. I designed a lot of it in some completely not open source software, which I'm just going to call Screw Up. You can guess for yourself what it is.
You don't really like it.
It's got a pretty low barrier to entry, and I kind of learned design stuff on the fly for other projects. I just sort of stuck with it. When you're doing this sort of stuff, you take your 3D image and you turn it into G-code, which is what Linux CNC understands. Now to do that, I use something else, which is also completely not open source or free or anything like that, which is Campy. Yep, sure that'll do. And when I cut it, I've got a home-built CNC machine made out of a thing called MDO, which is basically plywood with MDF cases, and then it's all impregnated in resin. But that's also, it's kind of open source, but they want you to pay for it. Well, you have to pay for it to get the prices, which doesn't really make it open source, really. But it is actually running Linux CNC. So I got one of, what was that, 4 things, which is actually open source, which, yeah, okay. And that's what it looks like. That's my machine, which I spent a lot of hours in that very leaky shed, standing behind, listening to it whine, and the dust extractor makes more noise than anything. There was 4 bags of dust about that big when I finished. I have a power dust mask, which is great because MDF is incredibly poisonous. And that's what the controls look like. Starship Enterprise, some people have thought, which is very generous. Now the plastic, which was also done in Screw Up, you cut it into, anyone who's done 3D printing will know you just use a slicer or computer or whatever you like, really just slice it up into layers, because it's printed that way. And then the Melbourne Hackerspace was very generous in printing them. The Prusa is mainly what we use, simply because the build platform is large enough that we can fit a whole kit on that one, in one run, basically. And that's a kind of blurry photo of the main kit that was used, which is owned by John Boschwell. He printed about half of them, and then Andy borrowed it and printed the rest. So, yes, it's a very serious 3D printer.
I broke it twice.
You broke it twice. You engraved the aluminium plate at the bottom. Should I have not said that?
No, I haven't done that.
Sorry. And that's on the Spaces prisoner. I think Stuart, you used my photo. I used your photo. It's just what I had. So yeah, that's it laying down the parts. Right.
How long's one layer there?
I have no idea.
A minute.
It lies.
A minute.
I mean, well, time to
No, okay.
You know.
I know.
It takes a minute for it to dry.
Of course, all the layers are different amounts of plastic,
Yes.
but towards the end of around, I get very, I know about the end of it.
Okay, I've got a very brief bit on the electronics, which I'll leave Luke to do the rest of.
Do you have any slides, or is that all you've got?
Maybe. Yeah, no, I'll let you talk about it. There you go.
I just need to grab this thing from the other room.
Okay.
Yeah, is it still locked?
I can put this online if you want to go to GitHub.
Okay. We could do that actually.
No, you don't?
Yeah. So we've got WebEx, and he's going to.
Oh, stop. Sure.
It'll be online in a sec, so you chat and I'll get it online.
Alright, so I don't really have anything to talk about until I get either get the picture or get the board. But anyway, so we've got this control board that controls the sensor chain. It's based on an Atmel 18MegaFuture. That's the same microcontroller that's used in the Arduino Leonardo. In the default machine that we're shipping, or that we're using today, it has an Arduino Leonardo bootloader firmware on it. So you use it with the Arduino IDE just like an Arduino Leonardo. But you don't have to use that firmware. You could blow it off and just write, hardcore low-level AVR code if you wanted to.
You could run German.
You could run all sorts of stuff on it. Software is left as an exercise for you to play with. So it's basically just the microcontroller and two stepper motor driver chips. We're using TI JRB 8811s. They're only small stepper motor ICs. They can maybe drive an amp or 2 amps into the stepper motor coils. So they can only drive a moderately sized stepper motor. But again, this was something that was really optimised to be really, really cheap and simple. Other than that, on the board you've got a voltage regulator that generates the 5-volt rail from the 12-volt rail. Unfortunately, it would be nice if you could just plug the machine into USB and it would just work. But you can't get 10 watts out of a USB port, so you can't run these motors off a USB port, obviously, so you do need an external power supply. We're just using 12 volts through a standard DC 2.1mm jack, so that's really convenient. You can just use any old plug pack if you did have one laying around or whatever. Miracle. It's a miracle. Oh, we're getting there.
Better to see more of than all those tears on.
I couldn't find them.
Let's try this. Magic of the open source.
Is it changing? Oh, you definitely felt it was like that.
It's not perfect. I actually generated this picture from the GURP files using a little rendering program, and I was playing around with the pan and tilt in 3 dimensions, and that's why this image is kind of distorted a little bit. Anyway, so you've all seen the boards earlier today, and this is just a rendering of what the board looks like. Could you make it like a stick or something? Point, that'd be cool.
Luke,
yes.
can you do me a favour and point out the little connector for the screen here?
Yes, so there's a little FFC ribbon cable connector 4 pins here that plugs into the touchscreens that Mitch was showing you before. Yes. Oh, awesome. So next to the, those little surface mount FFC connectors are really fiddly to solder and they're really easy to break and stuff. So next to it there's just a set of pads there, 4 pins, standard sort of 0.1 inch pitch, so you can solder in a standard header or wires or whatever. So that can be used if you want to modify the touchscreen cable or extend it or break it out or hack it in some way to, yes?
Since they go to the micro, you could also use them as GPIOs.
Yes, you could hack them to do other stuff, not using it as a touchscreen. They just go straight into the micro.
You've got your stepper motor drivers here, 2 trim pots that adjust the current regulators in the stepper drivers. Yes.
I noticed when we soldered them in, we didn't have to adjust or do anything to them.
Yeah. So when
I
you
want to run them flat out. They told me I shouldn't.
Yeah. Well, when you buy a trim pot just off the shelf, factory stock like that, it comes set in the centre 50% sort of position, and it just happens that we kind of got lucky with that it's a nice value at that point, which is good user experience. So we've got 2 stepper motors that are connected here, X and Y. We have the servo header there. The servo header with a small hobby sort of servo like that, it's just 5 volts ground and a digital microcontroller pin which takes a sort of PWM signal into the servo. There's a spare breakout header here which has step and direction, which is just 2 digital output pins and 5 volts ground and 12 volts. That's used so you can add an extra stepper motor on the system, but you need to add the actual stepper motor driver electronics externally. So it sort of has the capacity to be a 3-axis machine, but it was left off for cost constraints. We've got an SD card there, SD card socket. Now, I don't know how well we've supported this in the software yet. I think the software is non-existent. Nothing that doesn't exist.
I've got a card in mine, doesn't it?
Yeah, software contributions welcome. But basically the idea was, we've got this SD card, we've got the touchscreen, we've got the LCD display. So the idea was, with appropriate software, you don't need a PC. You could execute a program or a 3D plotting G-code or something autonomously off the SD card. And you just insert your SD card, boot up the machine, you get some feedback on the LCD, and you hit the touchscreen or something, and off you go. There are a couple of extra chips here. There's a 3.3 volt regulator and a non-inverting buffer to translate logic levels down to 3.3 volts, because SD cards are 3.3 volt SPO devices. Power comes in here, USB obviously. That's an 8-bit latch that drives the LCD using only 3 pins on the microcontroller, because you can just latch data in serially over 3 pins on the microcontroller, and then connect the 8 bits on the output side to your LCD, and that's perfectly fast enough for typical updates on one of those Hitachi LCD alphanumeric displays, and it saves you a lot of pins on your chip. And that's just the standard register, so it's like 20-cent part or something. As I was saying, power supply with a 5 volt output and a 5 volt rail, SPI programming interface for the AVR. That's pretty much it. Oh, there's some LEDs down here too.
And LCD contrast.
LCD contrast, trim pot, yeah.
And the Linux switches on top.
Yeah, there's a spare set of pads at the top there for XYZ home position setting switches or limit switches, so that the machine can set its use of data. Yeah.
E-stop.
Yeah, E-stop, whatever. They're just digital lines with a pull-up. Yes.
There are some inductors on the board. Is that for the switch?
I just lost the video, but anyway, there is an inductor which is the switch mode buck regulator 5 volt output. Yeah.
With 12 volt or 5 volt plug-in, how is it determining which one is it's using?
It actually just ties them together. It actually comes through a diode, so it won't inject power back into the USB port.
Okay.
You will get a 5 volt rail from either the 12 volt supply or the USB, so you can use either or both connected up.
But we recommend the power supply, so it goes up to 100 milliamps.
What are you using for that?
3463, it's cheap. It just works.
Cheap.
I noticed on my board, when I was unplugging, just rotating motors, that there was enough back EMF to light the LCD backlight.
Yeah, that's kind of weird. It depends what sort of architectures, obviously inside the H regions in the
Give it up now.
Hopefully we're not getting any compromising private information from Andy's email or anything.
It's all compromising.
anyway, I lost track of where I was. Oh, here we've also got a spare header there with 5 volts of ground and the serial UART on the 32U4. Because this is not a standard sort of AC Mega 328, something you might be familiar with. It's 32U4, so it's got the USB hardware port on the chip. And so we're not using the serial UART, so I just broke that out onto a spare set of pads so it can be hacked to do other things. There's also a reset button there on the board. You may notice that on the actual boards it doesn't exist because this is a later revision than the production boards.
Tell them what they don't have.
Here there's a set of LEDs down the bottom there, RX and TX, so that's just communications over the USB virtual UART for feedback and programming it. 5 volts and 12 volts, so you can see the status of both power rails individually, and XYZ, they indicate when the 3 home switches are closed. You can actually just test that by sticking a bit of wire across, just short out those switch pads on the board, and what you should see is that the LEDs there will light up if you don't have micro switches or whatever installed on your machine.
That's all that will happen. The code won't stop because it's not coded in yet.
Because it's not coded in yet, it doesn't matter.
What happens if you keep pushing against the end?
You're going to get because it slams against.
So what do you get? Is it a damage?
The stepper motors will do it. The stepper motors are pretty strong. It wouldn't surprise me if you tried, you'd probably break something. Yeah, probably.
Which is why you turn down the current with it, right?
Yeah.
Nah, don't do it. That's easier.
That's a quick question.
Yeah.
You mentioned before you were using Linux CNC to control.
Yep.
So how are you communicating the position to the chip? How are you closing the loop and getting around the whole USB real-time from
Okay,
the CNC?
Someone in the US has written a lovely little Python script that just acts as a link basically.
Okay,
It just
so you
shunts
use
it.
a user thread rather than a servo thread.
Yeah. There's no real-time feedback loop, so it's not really precise mechatronics with closed loop. Yeah.
You're talking about running this autonomously with the PC.
Why am I connected?
I'm scared. Something might be in my box.
Sorry, Mitch, I missed that.
Yes, so talking about running it autonomously, someone's going to interpret the G code. If you haven't got the PC running EMC2, what's going to interpret the G code?
Something like Gerbil can. I mean,
yeah,
it's not that hard to interpret G code. I mean, you've got to write a lot of rules for things like curves and arcs. But it can be done.
You can run Gerbil on this?
I'm not sure. I'm not sure if Gerbil works on the Leonardo. We did run Gerbil and we ran Merlin as well, but that was on a ramps board on an older Mega board. So we didn't test the Leonardo stuff that heavily with that.
Yeah, it's a very immature, untested idea. None of the software has been properly developed to do it yet. It may be challenging to make it work, but it's an idea.
What design software did you use?
Eagle. So the files are online on my GitHub account. They're Eagle files, but they're Eagle 5 point or 6 point something. Anyway, they're in the XML newer Eagle format, so you can use various tools to pass that XML, as you might probably be familiar with.
You used WebGerber for that, didn't you?
Yeah, I can't remember what the site's called, but it's a web-based. Yeah, that one. Yeah.
I noticed. I couldn't help but notice that there was a Freetronics name on board, so I went to the Freetronics website and found the article on the website. When they eventually become available,
there's even a price
will they be? Yeah, there is even a price there. Will they be the newer version with the reset button, or are we going to have? If we want to buy another one, because I actually want to take this board and use it for something a lot bigger than that, with similar size steppers, which will do what I need it to do. But I'm going to want a reset button.
Okay. We fabricated 100, so once those 100 are gone, then we'll do version 2 with the reset button. The other thing is that you can easily add a reset button through the ICSP.
Okay, cool.
Yeah. Or you can get a screwdriver or something and just poke pin 5 and pin 6 on the ISP header. Do you remember ever worked with like a PC motherboard where it's just sitting exposed on your table and you want to reset it, so you just poke it with a screwdriver and hit the reset pin?
Just grab an old PC case and rip out the reset button.
Yeah, that's
got
what
a header jumper already. Plug it straight.
Just be real quick with the jumper.
It's called hack CNC.
Just have to pull it low.
Yeah. And pin 6 on the ISP header is ground, which is right next to the reset one. Any other questions? Yeah, you may remember last year at LCA we had the Pebble thing, and we said, oh, we're going to manufacture more and distribute them through Freetronics. I put it up on the website, and it never actually happened because there was never any more stock. But hopefully this time we'll actually have it available.
We have the stock right now.
We're getting closer every year.
Yeah.
But look, the designs are all there, so these can still happen.
What about the other parts, the wooden bits?
Yeah.
Come on.
Well, because that was all done with, like, it was done in a really labour-intensive, manual, hand-lovingly crafted sort of way with love, with CNC routers and 3D printers and stuff. It was never really a good. It wasn't a sort of design for manufacturability, design for scalability sort of process. Yeah, but then again, we may be able to find some cheap contractor in China where we give them the STL or something and they injection mould 1,000 little plastic gears or something. I don't know, maybe.
They certainly look like parts if you run through a laser cutter, and some hackspaces in Australia do have laser cutters. Yeah, there's a DXF up there. You have to munch it.
Yeah.
Well, have a chat to Rob Britton. He actually knows a good laser cutting place that I get all my steel stuff done there. So.
The other thing I was going to say is if you wanted to change the design slightly, you could always buy something like MakerSlide and or 80/20 rails and basically make a whole frame arrangement yourself. It's not the cost. It's really not that hard to do. It'd be nice and rigid. There's all sorts of options you've got with this. The big thing is that once you've got the motors, you've got 80% of the machine.
Yeah, so there are STLs and DXF files and various 2D and 3D CAD files that are open source for the actual mechanical chassis and the 3D printed stuff, as well as the hardware. Yeah.
You mentioned the third axis. What is actually required to get a second motor driver? Is it just like a small breakout board for the chip or something?
Actually there is.
Before we get into any more questions, I'll just keep going. I've got a few pages on software. I can't remember what I wrote a few days ago. It was tired. Registered. So this is going to be chaos unless we're really careful about it. So what we're going to do is, first off, the people who have pre-registered and who have the names on the list, we're just going to make sure that you are here. And then after that, we will deal with other people that have come along that haven't pre-registered. We've only got a few sets of hardware and a little bit of space to accommodate extra people. So unfortunately, a few are going to be disappointed, but we'll do the best we can. So if you have pre-registered, please come along, see Andy, we'll mark your name off and we'll know that it's all good, and then we'll work from there.
Do it by calling.
So anyone who's pre-registered and paid, or?
You're better off doing it by calling it out.
Run anything this mechanical. It's been just PCB assembly. So what we're going to do, the way we found this works really well is if we have lots of helpers who give direct assistance as you're going. It's really hard to direct this sort of thing from the front because everybody goes at different speeds, you get hung up on different parts of the process. So we have a bunch of people who have already done assembly of these kits at the Hackerspace in Melbourne. They've run into the problems and figured out how to do it. So what we're going to do is have those helpers distributed around the room. If you've got any questions, ask people beside you, ask the helpers, and everybody can proceed at their own pace. This is not a race, so be careful with it. Don't force things. If things don't fit quite right, you know, we can make adjustments, and inevitably things won't fit. That's just the way it is. So we have some electronics assembly to do, some mechanical assembly to do. We have soldering stations all grouped down in that corner.
So if some people wanted to begin with the electronics assembly, that's cool. You can go straight to that. There are really three main parts to this. There is the mechanical assembly of the chassis. There is the assembly of the electronics, fitting the last few parts and wiring it together. And then following on from that, there is the software and making it all do what it needs to do. So most of you will probably start with the mechanical assembly of the chassis. Some of you can jump into doing the electronics and then come back and do the chassis later. That's probably the most sensible way to parallelize this. Now you'll need access to instructions. I notice that a lot of you don't have laptops. But there are instructions. If you go to Arduino Miniconf.au, there is a link to 2 sets of instructions. One is the instructions for the chassis, and another is the instructions for the electronics. We're going to be a little bit cramped. That's the other thing is, doing this sort of project, you need a lot more space than if you're just working on a PCB. So just be considerate of the people around you. We've basically fitted in as many people as we can in this room, but it is going to be tight. If you don't have access to the instructions, like you don't have a laptop with you, we can, sorry? Yeah, there's no way we can fit it all on the screen, but we'll just put some up and flip through it so you can get an idea. Yeah. Oh, right, yeah. Those are our network, good point. Is wireless here? No, it's not. Wireless is still down here. Yeah, okay, we're going to set up a laptop with the documents on it. And if you've got the little flash drive that came in your rego, we can stick it on that for you.
Yeah, I reckon get that one out in the pantry, and then just have a look at what, as people go, you'll see, you'll be able to get a little bit of it. Yeah.
Yes.
No, maybe here. We almost fingertips anyway. Maybe here. Get off. Would you like 70% solder? Yeah, I would. That's right. The idea, okay, solder, what you want is you've got two things that you want to join together. What you want is some solder between the two, which is going to act as a mechanical. And so what we want to do is get that joint between the two hot, then apply the solder, let the solder flow, take the heat off, and let the solder set to solid state. This header here is a good example. What I can do is show you on one here, and then you can do the rest. Sure. So you can put the header in.
Which way should we go? Like
this will plug onto the board here, so the header goes on the bottom, so that we can plug into the board later.
Like this?
Yeah. Shit that way is down across
Yeah, they're hard to get to. I think I'm pulled up.
And congratulations, you have
How are we going?
USB device unexpected and unmounted.
It's not quite so much wetting as it's called in CAD. So give that another go.
More solder or just melted?
Yeah, just a little bit of. Just try the heat first. Pull away. Perfect. And that action is where you're dragging away like that. That's good actually because that helps it perform.
Yep.
That's pretty much on the money there. And one final sanding check. Yes. So have a go at the next one there. Hold it large, but you probably actually grab the solder socket and tap it away.
So that hasn't taken up as much space as the other ones?
No, you could give it another hit just with the hot heat if you want to try and wet it a bit more, but
This
solder issues. Is that enough?
I reckon leave it on there just a smidge longer than you've been doing and you'll be pretty much on the running.
Oh yeah, that's fine. Oops. Yeah, that's fine. Generally with the multi-row thing like that, one of the things I'll do is I'll solder one checkered square and then solder the far end there. Because then it fits the square.
Just keep it on there a smidge longer for the next one. At this stage you can actually just keep coming down. Perfect.
So what happens if it accidentally spills across though, and then you've got too much solder?
There's ways we can put what's called a solder bridge, and we can. Nice.
And also it looks like there's a couple of little things over there you obviously want to stay away from on the other side.
Yeah, they're bios, exactly. They connect the top side of the printed circuit board to the...
It may be a matter of superstition, but I tend to skip pins so that I don't get too much heat build up.
Yeah.
Oh, okay. I'll do the odds and then the evens. Again, that's a matter.
Hey. What are we building there?
A hack CNC, hopefully.
Yes. Which component are you working on?
The Z-axis carry. So. I was cracked when we would work this game. My dad's a carpenter, a 6th generation carpenter.
You're just
being filmed. Sorry, Dad. Hope you're not watching this. It's embarrassing.
Someone's been designing it. Yeah, so it's pretty tight. Yeah, it's kind of trying to bring it all in at the same point. Excellent. Yep, that's really good. Yeah, so let me just get the display out of the way because it actually doesn't need to be involved in this part of it as well. Those cooperative, kind of yeah, that's pretty good.
Does it have to solder all the way around?
Ideally, yeah. You can only accomplish that just by heating it up a bit. You probably won't need any more at the solder on.
Yeah, we're going to do instructions of things.
We can contribute back to the instructions. What's the source of the instructions? What's it?
these little sticks at the registration time, I think?
So the first one took it out, they were the ones that actually read it.
Try that one on for size. The other thing I noticed was that the nut is wider than the other bits.
Because it's friction fit, it won't be too much of a problem. Flip it over and flip it over. Just like that, yep. Better? Look, once it's screwed in, it'll be tight in place.
So it's pretty.
Yeah, they only just fit through. You can't put them on
Getting there. Slowly getting there. There's a little bit of gap. Yeah, that's just another axis. So that's it, that's the x-axis and graphics. They milled out these ones. They were nuts.
Ah, these. Big brown.
Big jumps. We had some that were Is that the front plate? It's actually why not?
Goes on? Yeah, because some of them are kind of borderline.
Oh Jesus, tight. It'll go on, but it's tight. It's very, very tight. So what I did with mine.
Oh, you're just getting the alignment now, yeah?
Yeah, we're trying to super glue this thing here in tight. That's the, you can see it virtually working. You can do the y-axis up and down, x-axis, and the z-axis. But it's not connected to the real steppers yet. But when we're connected to the steppers in there, then it will. And you can see it on the screen there. I don't know how that looks in the video. You see the. This is the accent. Right. Sorry, it's called.
Start gluing.
Yeah, hack CNC.
Yeah. Okay. I'm tipping on montage this or something to some music.
We're only using X, Y, and Z. The home switches is when you've got end stops on.
Sorry. Are we getting second loss? This one must be that one there, which is that's the X mode.
Oh, right, okay. That makes sense. Yeah.
Hello. G'day. Don't mind me.
So we need a lot of other cables.
Limitations of your software. You're not allowed to say this is what I did. So let's software does this. No one's done it before.
So you basically
And it's only these two. They basically, if one goes one direction, it pushes the other way.
Bolt spacer board, board height.
Oh, okay, yeah.
So that just holds it firmly in another time. Yeah, you might want to mount it wherever you want to mount it. You need to put, this is the y-axis. In the electronics instruction, it does have the order of the y-axis. So that's ready. You have the y-axis. This is the x-axis. G'day.
Hey, how you right?
Just take a sec till I get a couple of things set up.
That's all right.
They had it on the station there. I just need to. Make it do it again, but I have to put a pen in here.
Yeah.
There we go, that just sort of fits in there so that it stops it moving. That basically just stops that piece coming off, particularly if you pick it up here. It might pop off the edges, but it won't pop off the entire piece.
No, I am now recording, so at your leisure.
Okay, that'll be a little bit more easy for us to have a look at. There we are. So we've got two inputs, and I can click on them. Can't click on audio. Can't click on. Oh, it's not on. I think that'll fix it. Okay.
We get the do the demo after.
Yeah, I'll have to do the demo after. But so that might be the better way. But it's highly flexible. So Modbus is available. You can communicate with Modbus to many things. One of my jobs when I leave here is to go to a country town and interface a PLC with Modbus to a PC and capture the weight of that bale, but capture it with intelligence about what's going on in the machine. Because the problem is they press capture and the bale's already half loaded the bales and the weight's shot. It's useless. So if I can capture the weight when the bale's where it should be and steady and all those sorts of things, and I can put little interlocking bits in the PLC and in the software between it such that they've got to press F5. Press F5, the bale loads. If they don't press it, the next bale doesn't load. You keep sort of pressing the key and you've got the machine under control. From the point of view of your sort of things you might want to do, Jonathan has a lovely super house with all these lights wired up and all these roller doors working and all these sorts of things. And I assume he's used Python or Perl or some language like that to join it all together. But it's a lot of infrastructure, a lot of custom code every time. You can write a very simple little machine in here that says, here's an output, here's an input, here's a light. here's some rules, you know, I don't want to be on for more than 15 minutes, or I've got an IR sensor in the place of the IR sensor is on for more than, or off for more than 10 minutes, turn the light off. In the config file, he would just simply say we were going to create that. Let's go up the top here. He would say something like room 1, and he would call it simple light. And he might say, look, I'm going to put it in, you know, general for the tab, for the web page. But of course, you can write your own web page. The system uses a thing called 0MQ for all of its general communications between all of its connector programs. We hope to add, make the, well, in fact it is already very simple. The QMTT stuff has been fairly well integrated into Clockwork in the sense that not only of those points I mentioned, there's also this idea of subscribe and receive commands such that you can say to a machine, I want to receive something, and subscribe to something, and then when I receive a message, I can process that in my state logic. But so we've got this here, and then you say light or room 1, switch 1, and room 1 light. He's now got his room configured. Yeah, no more work, standardised program. If he wants to write a simple, more complicated thing that takes advantage of other information, that's a simplified thing as well. And it's just a set of passed-in parameters. We also do the idea of, within our machine, we'll do an instantiation of a persistent variable. So when we can generate the idea of persistent, really, are we? Okay. Well, I'll just quickly show you. Well, okay. We have this idea of persistence, so we can say to a machine, your options, your variables, are now persistent, and they get stored in a little database. Every time the program wakes up, that information gets reloaded into that machine's context, and result timers, anything like that can be stored. A number of times the light's been turned on and off. It can be stored forever. You know, that kind of stuff. So let's have questions.
Any questions for Mike?
Gentleman in the middle at the back there.
Your code's on GitHub, is that right?
That's right, yes. It's, as I say,
what license?
GNU 2, I think. Yeah. So we've got the laptop project there, and we've got this thing we're calling Inquino, which is the code we're writing for here, which was this generic way that you don't have to know anything about code, you just load it on there, and then you can start to use it. This here is, I tried to show you, is a simple driver board that drives these solenoids and takes inputs just using a voltage divider from the 24 volts.
So would you say this is like a better Fermata, basically?
I didn't catch the last one.
Fermata? Like, it's Fermata, right?
Yes, yeah, that's right, yeah. I've not seen Fermata.
Okay. So Fermata is like a piece of firmware you put in, it lets you drive everything from the computer. What I find interesting here is like also, it's all event driven instead of being simply the INU.
So I have a...
So, but the things, what would be interesting in the comparison, see like performance-wise or feature-wise, is it like...
We will eventually get, I hope, everything.
That's yeah. I think.
Well, I'm hoping that we'll get to the point where we can control every single peripheral that's on these devices and gather information from them. It's event-driven. I have a real peeve. I don't like things that poll. I hate them.
Yeah, it's awesome.
So everything's event-based.
Is it a PHP interface using the event?
No, that's just hand-coded PHP with HTML in the thing. It's not secure in any sense at this stage, but it's just using 0MQ PHP bindings. And you can list objects. So what we did was, can I still run that up? Yes, I can. No, I can't.
Well, we can talk after.
Yeah, but we've got this idea of you can log into a shell and you can describe a machine which tells you what the state of all the inputs and outputs are. There's a ZMQ listener, basically, so you can see all the messages that are being sent throughout the system. You know, we had the machine that I just ran up just there, just to give you an idea of the this machine. This is a machine here that we did. It's if I run that.
I'll come talk to you after.
Yeah,
because I think it won't
just quickly look at that. That's not. Let's go back one more. Is it? Yeah, that is 541 active machines with 319 passive machines running on a 1.6 gigahertz Atom machine and did the job on this Beckhoff I/O at a 1 millisecond update on all I/O points, about 250 I/O points, plus a video camera for capturing bale pictures at the head of bales. We had a piece of Python code running that displayed all that in the POP-Q type system, all driven from here from the point of view of messages being passed and all that kind of thing. So it's very flexible, I think. And I believe we couched it wrong when we were talking about it for the Linux conference, but you know, if I couched it this way, I think a lot of people would enjoy it. So thank you.
Davis, yes, I'm from Melbourne, but now I live in China. Some things you can get really cheap in China, like electronic parts. This is a touch screen that comes out of a Nintendo DS. And there's a little connector on your hack CNC boards that lets you plug in a touch screen, which would let you play around with a touch screen without having the PC connected, in theory. Okay, so these guys are recipes from a DS. The idea is that you touch it somewhere on the screen and you can read the little values out the little tail on the end of it, little tail. Can we see that there? Yeah, little tail there. And you can use that in your application. Now, the way touchscreens work is, if you have a resistor here, you can set up a resistor divider network. So the idea is, as you move this up and down, you're going to get a varying voltage there. Now, a touchscreen is a layer of glass and a layer of plastic. And there's a very small air gap between them. When you push with your finger, the two layers will touch each other. And if you touch it up near the 5-volt end, because you'll get a varying voltage across there, if you touch it near the 5-volt end, the bottom plate will be close to 5 volts. If you touch it near the 0-volt end, it'll be close to 0 volts, and you can read that voltage off there. All right, okay. Now, you won't see that in PowerPoint. No. Okay. Yes. So when we have our little touchscreen, we have 4 wires, one along each edge, that come out on this little tail here. So top, bottom, left, and right. When we're reading the X, yes, what we do typically is set this to say 0 volts, this wire to 5 volts, and then we use the bottom wire as our sense wire to see where it's being touched, like the resistor divider we saw before. To read Y, we do the same thing, except now we make the top 0, the bottom 5 volts, and we read off one of the side wires. Now the thing that lets us do that is that inside the AVR chip that's inside every Arduino and also in the hack CNC boards that you had today, is that, okay, here's the chip with a number of I/O pins on the side. You can set different modes for these pins. So you can set a particular pin to be high, so it can provide 5 volts. You can set it to be low, so that it will it'll be 0 volts on here. You can make it so that it's not connected to anything, or you can read the voltage that's there on the pin. Now, when you're reading those voltages, it's a 10-bit converter, so you get a signal you get a number from 0 to 1, 1023 that you can feed into your software. All right, so the idea is that you set up those pins for 5 volts and 0 volts, and reading off it for X, you read the sense wire, you set that up for Y, you read the sense wire for Y, you do something with that data, and then we'll go back up to the top because it'll be really fun. All right, now, What got me started in this was partly some stuff that John wrote in his lovely book, Practical Arduino, and also some stuff that Andy did when we realised that we've got a project that's got a bunch of switches and they cost money and it ends up adding up. So the idea is that you take a touchscreen like this, and if you want to have 3 or 4 buttons or something like that, what you do is you get some card, you print out on the card the buttons that you want, you slip it under the touchscreen, and that becomes your interface. Now, these guys are made of glass. So if you drop them, they break, and then we all cry. And also, if you slip them into the little connector on your CNC board, and then you put the little latch on, and then you have that hanging off, the little tails can break off very easily, and they don't work very well when you break the tail off. So, yeah, apart from that, you get lots of good fun. Where can you get one? Well, the good news is, everybody who made a Hack CNC today, I have a touchscreen for you, absolutely free. I live in Shenzhen, China. I can walk 2 minutes down the street into the world's largest electronics market, which is pretty damn cool. And they're one of the spoils of being able to live there.
Plus they're rubber to Australia.
Yes, I did bring them here, a minor detail. All right, okay. You can also buy them from online gadget sellers, for example, Good Luck Buy. They're only about $3, including shipping. If you want help using them, get to your local hackerspace, or you can read John's fine book, Practical Arduino. This particular chapter, I think, is also online. Lots of good info there. Yes, thank you for listening to my lightning talk. And yes, my name is Mitch. So if you've got Hack CNC, you come and see me. I'll give you one of these touch screens. Thank you.
Right, software. Here's a very quick run of how you actually get something out of it. The best way is to just have a go with Inkscape, because if you've got the ISO that we had loaded up, that's installed with the G-code extensions. Draw your picture, use the export to G-code tool. I found on my machine a negative Z-axis movement was enough to push it down with enough force to hold the pen. You're going to have to play a little bit, unfortunately, because everyone's a little bit different. And then just load the file in Linux CNC and hit the big start button. We've got a few ideas on how you can take it to the next level. Freaking laser beams is very, very common. We don't have any at the moment, so it's unfortunate. So what I did put up there, actually, I wonder if I was to use it to run an old a knitting machine, which takes a punch card, sort of replace that to run on something a little bit more modern. So that'll be fun. Yeah, there is a fair bit, or there's a lot you can do with it. I would highly recommend replacing the rails if you ever get the chance or know how to do that, just so that it runs a bit smoother. That's the last of my slides, so now we can move to questions. I should say a big thank you to everyone at the Hack Space and Electronics, and everyone who helped with this. There was a lot of people. There is a list of them on the documentation, which I left my name on. So, yeah, questions?
I guess just on behalf of the attendees, we'd like to thank all the organisers and all the work that all you guys did to put it all together and make these kits available for us. So.
Anyone else?
Maybe we should just add, we've got the Arduino Miniconf mailing list, which is a mailing list by Google Groups, so it's all easily publicly, you can add yourself to that and post stuff and whatnot. So that's the place to go for ongoing questions or support or follow-up or ideas or whatever. Ongoing discussion like that would be good. Also, any ideas of any stuff that the community might be interested in or what you might like to see at the Arduino Miniconf next year or in the future, if it happens again. Probably will. Because I think maybe they don't know how to say no to Jonathan. So, John Oxford, any talk? Yeah, it's done. Any Miniconf? Yeah. You know it's quality done. So yeah, that's the place to go if you want to discuss any further ongoing questions or anything.
Okay, and the GitHub, of course, which is /cchs-melbourne/hackcnc. You'll remember that, you'll be fine. It's on the documentation.
Just one more question about the board. The servo output, is that a direct route back to the processor? Or
Yes.
Is that,
So
okay.
it's
So you could
intended to drive a narrow use case, which is a very small 5-volt hobbyist servo, like the sort of thing you use to control the control surfaces in a little plane.
But if you're using something like a laser, you could hack the code to just toggle it on or off, switch a fed or something like that.
It's directly off the micro, so yeah, a transistor or some sort of driver circuit would need to be added.
The little MOSFET driver that Freetronics sell.
For example.
I've used two of them, I think I've talked about.
Yep. Anything else we need to cover?
I might just mention us on page well, I guess this is the end of what we formerly planned, and there's sort of I've got a room to clean up, and the people will want to finish their machines. So I think what we'll do is we'll come to a close, help anyone who needs a little bit of help just cross the line, start to pack up. We'll have dinner, we'll think about it, and we'll announce how we'll go forward on LCA chat. I think that's so we'll put up URLs that people mentioned,